Hey class, this PowerPoint audio presentation is intended to clarify the concepts that we talked about in class the other night, last Tuesday, around the concept of time value of money. And time value of money has four primary components: present value, future value, annuities, and amortizations, which amortizations being payments that you make over time at fixed amounts. So it's like a house payment or a car payment. And the cornerstones again is that money will grow over time when you're receiving interest, and therefore money that's received at some time in the future is going to be worth less than if you took a similar amount of money today, received today. And it can be perceived really from two perspectives, that whether you are paying a debt off or whether you are receiving debt, you're interested in the value of those amounts, both in future dollars and today's dollars. So the future value, I'm just going to say, I'll make a real quick point of this. Future value looks at just exactly what it says, the value of money that you receive in the future. And it's a multiplication problem as a consequence of that. So let's say that you are to receive 8% per year on $100. And then we'll take a look at what's it worth after 1 year, 5 years, and 15 years. So if I multiply 8% of $100, I get $8. So at the end of 1 year, I would have my original $100 plus the $8 that I received in interest. A simpler way to do that mathematically, however, is to add your interest rate to 1, and because the 1 represents all of the $100, so I will have all of the $100 plus the 8% that I earned at the end of a given time period. So 100 times 1 plus 8 interest for 1 period is going to be equal to $108. After 2 years, that is 100 times 1.08 for the first year, which we know to be $108, and then you earn interest on that amount of money. So that would be 108 times 1.08 again for the second year, and then the total amount, therefore, that I will have at the end of the second year is $116. This is called compounding, or interest accumulated on interest. And it is how you make money if you want to retire over time. You want to be getting compound interest. So this is the same thing with a little bit more detail, the same questions. We calculated what we get after 2 years. 1 year, and then we looked at 2. So 5 years, it's just the same thing as before. Instead of with 2 years, we had 100 times 1.08 times 1.08. But since it's 5 years, we would do that 5 times. And at the end of 5 years, we would have $146.93. Again, a simpler way mathematically to express that is to say we have our $108 times 1.08, which nests our interest rate, to the 5th power. So if you look up after above where it says after 1 year, you see there's a number to the upper right corner of the 1.08, and that number is 1. And so every time we add a year, we add a number, we change that number because it is a reflection of the number of years that we're calculating or compounding this interest. So we just said it was to the 5th power. So what you see as 1.08 to the 5th is exactly the same mathematically as what you see immediately above it. And 1.08 to the 5th is $146.93. The reason we want to reflect it, obviously, as that to the nth number is that it gets otherwise very complicated in writing it out. So after 15 years, it's 100 times 1.08 to the 15th power. And what you see on the bottom right corner is the future value is equal to the present value of the amount that you're talking about, which in this case was $100, times 1 plus the interest rate, all to the nth degree. And there you have it. So why are we interested in compounding? Because as you go out in time, your money starts to accumulate much quicker and significantly because you're getting interest on interest. Now, we're all interested at the end of the day in how long does it take me to double my money? Well, if it's 12 years, I can tell you it's about 6 years. In 10 years, it's about 7.2. How do I know this? Well, read this article on what they call the 72 rule, which is an accurate way to estimate the amount of time it takes for you to double your money at any given interest rate. So I said that at 12% it's 6 years, so 72 divided by 12 is 6. 10 is 72 divided by 10 is 7.2 years. So the amount of interest that you're making is significant in determining the pace or rate at which your money is going to increase in value. Now, whereas future value is a multiplication exercise, present value is just the opposite. It's a division exercise. And so if we wanted to calculate the present value of an amount of money that I was going to receive 1 year out, we would divide that amount of money times 1 plus the discount rate. They changed the term from interest rate to discount rate. You discount it. And so common sense would tell us that if we're earning interest at 8%, and after 1 year we would have accumulated $8, so the total thing should be worth $108. If I were to discount that amount for the same amount of money, then I would be dividing $108 by 1.08 to the 1 degree, and that would give me, common sense, $100. So let's look at this and use a different amount of money. Let's say that you expect, we'll look at it a little bit differently, and let's say I owe you $100. I borrowed $100 and I'm going to pay you back in a year. I'm not going to give you any interest on it. I'm going to give it to you in a year. This is where present value is really important, because if you are expecting to receive payments over time in fixed amounts of money, you should understand that those amounts of money received at later dates are not worth what they would be at an identical amount right now. And what we want to do is we want to evaluate what those amounts of money that we're to receive in the future would be worth in today's dollars. Is that significant? Yes, because if they're less than an amount in today's dollars, they don't have the same purchasing power of a dollar that you would receive right now. So that's why we calculate present value. We call it present value. It's taking an amount received in the future and translating it into a value equal to an amount in today's dollars. And it's a subdivision problem, not a multiplication problem. So let's say you expect to receive $100 in a year. If you can invest it at $10 today, at 10%, what's it worth in today's dollars? And again, you do the opposite of what you do and calculate a future value. Instead of multiplying 100 times 1.10 to find out what the future value is, you divide that future value amount by the discount rate. We call it the discount rate. So it'd be 1 plus 0.1 plus 0.10. So there should be a decimal in there to the 1th degree because it's one time frame, and we would get $90.90. So that means that if Dan owed me $100 a year from now, if I could talk him into it, I'd say, I'll take $90.90 right now because I think I can make 10% on that amount of money. So again, present value is discounting backwards from a future amount, and it's a subdivision problem or division problem. So same. So future value times 1 divided by 1 plus the interest rate to the nth degree, where n is the number of time periods that we're talking about. And if I were to expect to receive $100 in 8 years, what would that amount of money be in today's dollars if I have an opportunity to invest it at 10% right now? And the answer is $46.65. Here's another way to state it. Dan's going to give me $100 in 8 years. If I had a surefire investment where I could make 10% on my money right now, I would tell Dan, please give me $46.65. I put it into an investment at 10%, and in 8 years, it's worth $100. That's the relationship between these concepts. So this is just a repeat of the future value. Future value at the end of different time periods. I don't know why this was in here. So there's the equation for future value. It's a multiplication problem. You take the present value of an amount of money, let's say $100. It's answering the question, if I put this investment into a savings account at a certain rate through n periods of time, what's it worth at the end of that period? If you put $100 into an account and it earned 8% per year, you get interest on your interest every year. At the end of 15 years, that $100 that you put in your savings account and earned 8% interest would be $317.22. At the same time, if somebody were to say, I will give you $317.22 15 years from now, and you thought you could earn 8% on your money, how much would you take today? And the answer is you would better take $100. So annuities are interesting because annuities have two sides to them. What is an annuity? It is an investment that you generally make over a period of time, and they're usually fixed amounts, like money toward your retirement account or a pension fund amount of money, and you make these investments on a regular basis. They can begin to differ over time on a monthly basis. Let's say that it's 5% of your salary and you get a raise after the third year. Well, you'll be contributing a little bit more. But the point is, you make these investments over time into an account with the expectation that one day you will take those monies out. In this instance, when you retire. And so you're interested in two things: the future value of those monies that you're depositing at a certain rate over time. But at some point in time, when you start to take them out, you're no longer interested in the future value. You're interested more in the present value. So let's say that you know over 10 years you're going to deposit $10,000 at certain rates, let's say $1,000 each year. It's going to have some future value. And then if you start taking out 8% of what you've accumulated, you want to know what that amount of money that you're now taking out for your retirement is equal to in today's dollars. What everybody that wants to retire strives for, or should strive for, is a present value amount down the road that they've deposited enough money that if they want to live exactly like they do today, they have to have deposited a given amount of money such that when they begin to take it out, the present value of the amounts they're taking out are equal to the present value of dollars that they're living on today. So that would just imply, I'm making this up, that if I live on $1,000 a month right now, that I would probably have to take out $1,500 or $1,600 in the future when I retire to live identically to what I live like on $1,000 a month, because those dollars in the future aren't worth, in terms of amounts, that exact amounts that they are now. So that's the correlation. Hope that makes sense. So again, from an annuity standpoint, we're looking at the future value of those cash flows or deposits that I'm making, and then eventually I'm looking at the future values of the cash flows that I'm taking out on a regular basis. So it's a two-part exercise. First, it's a future value. You make deposits over time, just like a savings account, because that's basically what it is. But then you turn around and look at those cash flows that you're taking out. So the first part, The previous slide, I'm depositing for 3 years. Then I turn around and I start to take out cash flows, and I translate those amounts into present values or today's dollars. And it's important that you understand that concept that, wow, I'm going to be taking out $10,000 a month out of my annuity. Yeah, that's fine. But if it's 20 years before you can take out $10,000, what is the value of that $10,000 extractions in today's dollars? Because if it's only 5,000 in today's dollars and you're living on 10, your lifestyle is going to be cut in half. Now, amortized loans, again, examples would be things like mortgage payments in cars. And the book provides formulas for determining those payments, but I downloaded um, the amortization schedule calculator that I talked about in class. I downloaded it into the shell of Module 3, and you can download it. If you see the title, when you go to download it, it says amortization schedule XYZ, and just below it, it says download and amortization schedule, and you can download that onto your laptop, and you're welcome to use it to solve the problems in the text around amortization, unless you want to do it by hand, in which case, go for it. Now, I don't lock sales on this, so I'll tell you that in the first two lines, green on one side, kind of bluish on the other, I'm looking at the screenshot that says 12% interest rate, 5-year term. If you want to change the interest rate, change them in that cell. If you want to change the term from 5 years, if it's a 30-year mortgage, change it in that cell. And interest rate would be like 0.08, term is term, and you can change the amount financed, in this case, right under mortgage loan analysis. But it doesn't have to be a mortgage loan. It could be, like I said, a car loan. Now you drop down a little bit further and it says loan amortization schedule. You've got the principal there, which is the amount borrowed, 10,000, interest rate, so on and so forth. Do not change those numbers. And again, I did not lock the cells. Don't change the numbers in those cells. They're read off the other ones. And so if you want to change the interest rate, the term, the amount borrowed, amount financed, do it in those first green and bluish ones. And then in doing so, you will identify the monthly payment, change in the monthly payment, which is shown in yellow. And then finally, a little spelling error I see, chose a company, should be choose a company. Here are the companies that we talked about that you can do your reports on: Tesla, Netflix, Rocket Fuel, iRobot, Sierra Wireless, NVIDIA, Skyworks, etc. Real quickly, I'm not standing by any of these, but I think Tesla's stock, if you want to look up the stock amounts in MSN, it's TSLA. I think Netflix is NTFX, I think. Rocket Fuel is Fuel, F-U-E-L. iRobot is IRBT. Sierra Wireless is SWIR. NVIDIA is NVDA. Skyworks, I think, is SKYS, I think. Seattle Genetics is SGEN. Billicom Pharmaceuticals is BLCM. Google is like GOOG, I think. Johnson & Johnson is JJ. IBM is IBM. Procter & Gamble is PG. And Dry Ships is DRYS. So, good luck on those. I'll give you some more detail on what I expect in your assignments, but I will say I'm looking for a 2.5 to 3 page double-spaced or 1.5 spaced write-up, as well as probably I'm thinking 6 to max 8 minute overview of the company and its primary financial facts and figures. It would include a description of what the company does and the industry that it's in, what's going on in those industries, relevant things like price earning ratios, market capitalizations, and amount of risk, and we'll talk more about some of those parameters. My advice is get started on learning about the company ASAP so you can track its progress over the next 5 weeks or so.